Chapter 6, Lesson 1, Rational Expressions. So today we're going to be talking about rational expressions, which another word for rational is fraction. So we're going to be talking about fraction expressions here. The first thing we're going to talk about is how come a rational expression or a fractional expression is considered to be undefined if the denominator is 0. So I'm talking about if I have 3 over x, how come x cannot be 0? Well, that's because the number one rule in math is you cannot divide by 0. So when we're doing these problems and we're talking about our intercepts, remember we're solving for x here on all of these. In these cases, since x is on the bottom of our fraction, we have to solve, and whatever we get x to be, when we set it equal to 0, that cannot be a possible option for our intercepts. In this section, we're also going to be using set builder notation, which has been a long time that we've used that. So remember, in set builder notation, we are using all x's such that x is, and then we usually write something about the x, some sort of a sentence here about the x, and then we close our bracket. That was back at the very beginning of our book. So in this first example, we have 3x plus 7 over x minus 1. And so x could be any number except positive 1. X cannot be positive 1 because positive 1 minus 1 would be 0, and you can't divide by 0. So when we're using our set builder notation, we say the domain is all x's such that x is a real number, comma, or but x cannot be negative or positive 1. Okay, on this one, notice that there is not an x in the denominator, so we don't have to worry about it not being able to be any number. So for this domain, I would say all x's such that x is a real number, and that's all I need. There's no but. X can be anything. On this one, it's kind of like what we did before. So x cannot equal 1 because that would make it 0. So the domain is all x's such that x is a real number, but x cannot be 1. On this one, if x was 5, 5 minus 5 is 0, and 0 times anything is 0, so it can't be 5. And it also cannot be negative 3. So my domain is all x's such that x is a real number. Oops, forgot my symbol in the middle there. But x cannot be 3 or 5. And on the last one, we're going to have to factor it first to figure out what these numbers are. Factors of 6 that add up to 5 are 2 and 3. Sign chart says they're both negative. So x cannot be 2 and x cannot be 3. So my domain is all x's such that x is a real number, but x cannot be 2 or 3. Okay, the second thing we're going to be doing is simplifying rational expressions or making them smaller. So just like when you would simplify fractions in the past, if you had 4/8, you would divide them both by 4 and simplify it down to 1/2. So that's what we're going to be doing here. We're going to be trying to get rid of x's and get rid of numbers and get rid of sets of parentheses and break them down into smaller terms. So we're going to be factoring, and then we're going to be eliminating any common terms. So on this first one, the top is a monomial, which we can't do anything with factoring. But the bottom down here has a greatest common factor, and they have in common 2x squared. So when I take that away from my 10x to the third, that would leave me with 5x. And when I take 2x squared away from 2x squared, it seems like nothing, but I at least have to put a 1. Now, once I've simplified or factored the top and the bottom, I can reduce anything that's a like term. So my 2x squareds would cancel each other out. And my final answer would be nothing left on the top, so I got to at least put a 1. And on the bottom, simplified down to 5x minus 1. So now my domain could be anything except for positive 1/5. So my domain, all x's, such that x is a real number, but, why am I writing the word but? X cannot be 1/5. Okay, on number 2, it looks like they both need to be factored, and the way they're set up, they both need window method factoring. 9x squared plus 4. 9 times 4 is 36. Things that multiply to be 36 and add up to 13 are 9 and 4. Sign chart says both plus. So x plus 1, 9x plus 4. Okay, now the bottom. 8x squared minus 7 is 56. Factors of 56 that subtract to be 1, 8 and 7. Sign chart says the bigger one gets a plus. X plus 1, 8x minus 7. And so now reducing, these two would cross out because they are the same, and I would reduce it down to 9x plus 4 over 8x minus 7. The bottom here, the top is a monomial, so it's fine. The bottom has in common 5x to the 4th, which when I take that away would be 2x. Take that away would be negative 1. Those would cross out. And I have 1 over 2x minus 1. And on this last one, they both need window method. 5x squared plus 6 is 30. Factors of 30 that add up to 13 are 10 and 3. Sign chart says both plus. X plus 2. 5x plus 3. 5x plus 3. X plus 2. And the other one also needs window method. 6x squared minus 10 is 60. Factors of 60 that subtract to be 7 are 12 and 5. Sign chart says the bigger one gets a plus. X plus 2, 6x minus 5. These would cross out because they're like terms, and my final answer for this one would be 5x plus 3 over 6x plus 5. Go ahead and pause here and take your notes about multiplying rational expressions. So in this case, the first thing I would do on this top one was put this in standard form. This monomial on the bottom is fine. On the top right, I would take out the 2. Oops, that would be x minus 2. And this bottom one on the right side is a window method. Factors of 3 that subtract to be 2 are 3 and 1. Sign chart. I'm leaving with x minus 1 and 3x plus 1. Good. Then I look for anything that could reduce, so these 3x minus 1s are going to cancel each other out. These coefficients of 2 will cancel each other out. And so it looks like I'm left with x minus 2 over x and x minus 1. I got the x from here and the x minus 1 from here. And none of them can reduce, so I know I did it correctly. On the second one, standard form on the top here, take out the 3 over here, leave the monomial alone, and window method, the 5x squared minus 2 is 10. Factors of 10 that subtract to be 3, 5, and 2. Sign chart, x minus 1, 5x plus 2. 5x plus 2, x minus 1. Okay, so the 5x plus 2's cancel each other out. The 3's cancel each other out. And I'm left with 2x plus 1 over x times x minus 1. On this bottom one here, I need some room to work because I see that this first one is a sum of perfect cubes. So my A is x and my B is 1. Difference of perfect cubes, sorry. So that would factor into A minus B, A squared plus AB plus B squared. 15x squared is fine. This we would take out a negative 3. And I don't have to factor this one because I see that it will cross nicely out with what I have there. My x minus 1s will cancel each other out. So far I'm left with 15x squared over negative 3, which 15 over 3 would reduce to negative 5 x squared. And you could put it over 1 if you wanted to, but that would be my final answer. Okay, talking about dividing fractions. So remember, we've talked about in the past, or you've learned somewhere along the line, that you cannot divide fractions. What you do is you multiply by the reciprocals. So that's what we're going to be doing here. So we're going to be flipping the second one, and then we're going to be following our rules of factoring and simplifying. So on this first one, 8x squared is a monomial. On this 3x squared minus 12, first I would take out a 3, which would leave me x squared minus 4. And then I also can factor that x squared minus 4, x and x, 2 and 2, 1's a plus, 1's a minus. Now on the second one, I'm going to have to flip them. And I also want to put the top one in standard form. So I'm going to have negative x plus 2 and now 40 on the bottom. And then I'm going to take out a negative 1. So I have x minus 2 for my final factoring. So now my x minus 2's would cancel out. And 8 over 40 become 1/5. And that should be everything. So on the top I have negative 1 left. And on the bottom I have 3 times 5 is 15. Because remember when we flip it, this becomes a times. X plus 2. On this next one, first of all, there's a typo. This should be an X. And also, all of these are going to be window methods. Every single one. We're going to have 4 window methods here. So you're going to need a lot of room to write this one out. So I'll try to do each one a different color. So we'll start with the top left. 18x squared plus 1 is 18. Factors of 18 that subtract to be 9. Oh, this was a 2. I'm like, that doesn't seem right. How about 36? Factors of 36 that subtract to be 9. 12 and 3. Sign chart says bigger one gets a plus. 3x plus 2. 6x minus 1. Okay, bottom left. 24x squared plus 1 is 24. Factors of 24 that add up to 10 are 6 and 4. Sign chart says both minus. 4x minus 1, 6x minus 1. Okay, top right, which will now be actually our bottom left, because we got to flip that second fraction. 3x squared plus 10 is 30. 15 and 2, both plus. X plus 5, 3x plus 2. So I'm writing this one down here because remember, we can't divide fractions. We have to multiply by the reciprocal. Okay, and then finally we need to do this last window method. So 8x squared minus 5, which is 40. Factors of 40 that subtract to be 18 are 20 and 2. Sign chart says bigger one's a plus. So these have in common 2x plus 5. And these are 4x minus 1. Again, I'm putting this on the top since we can't divide fractions. We have to multiply by the reciprocal. All right, then we'll cross out anything that we find in common on the top and the bottom. So this would eliminate with this one, 6x minus 1s, the 4x minus 1s. And so our final answer would be 2x plus 5 over x plus 5. Just a couple more examples here. On this one, when I go to factor, this one I'm going to put it on the bottom, and I'm going to be taking out a negative 7x, just a negative 7, sorry. A negative 7, so that would leave me with x minus 2. And on this one, I'll take out a negative 9, which would leave me with x minus 2. Those two would cross out. My 7s would cross out. My negatives would cross out. And I'm left with 9 over 3, which reduces to 3 over 1. On this one, I'll factor x plus 2, x minus 2. Flip this to the top. Flip this to the bottom. Cross out my x minus 2s. Cross out my y squareds. 6 over 3 reduces to 2 over 1. Take away 1x, take away 1x. Final answer, 2x over x plus 2.